In a climate-controlled lab, where the hum of machines blended with the quiet focus of scientific minds, something unusual was about to unfold. A single blinking light on a monitor suddenly pierced the calm, signaling an anomaly that no one had anticipated. Scientists at the U.S. Geological Survey were running routine checks, sifting through endless streams of satellite data, expecting another uneventful day. For years, the Appalachian region's data had been predictable, a story of slow erosion, gentle shifts, and geological calm that rarely made headlines. But today, the numbers screamed for attention, breaking the monotony with a surge of alarming data. A pattern emerged that made heartbeats quicken, a signal so clear and persistent it seemed like a glitch. Yet after running diagnostics and double-checking every system, errors were ruled out. The data was real, undeniable. Something profound was happening along the ancient spine of North America, a region thought to be geologically quiet. The Appalachian Mountains, older than dinosaurs and silent for eons, were stirring from a deep, timeless sleep, as if awakening to a new era. A junior analyst stared in disbelief at a topographical map suddenly alive with red warning hotspots, each one a beacon of the unknown. The data pointed to a phenomenon that textbooks declared impossible for this region, especially on such a short timescale. It defied everything they had learned. Mountains are supposed to rise over millions of years, shaped by slow, relentless forces, not in mere months, as the data now suggested. The discovery sent a ripple through the scientific community, sparking urgent meetings and frantic calls across continents. The Earth was sending a message, one that echoed through every lab and office. It was our job to decipher it, to understand what the planet was trying to tell us. The implications were staggering, touching everything from planetary dynamics and climate models to the safety and future of millions living nearby. The ancient Appalachians were ready to reveal a new secret, one that could change our understanding of the Earth itself, and now more than ever we had to listen. Our story begins not with a hammer and chisel, as you might expect from tales of ancient geology, but with satellites and radar, peering down from the silent vastness of space, capturing secrets invisible to the naked eye. Using interferometric synthetic aperture radar, or InSAR, these advanced satellites can detect even the slightest ground changes down to just a few millimeters across vast landscapes. For months, InSAR data painted a startling picture. The central and southern Appalachians, long thought to be stable, were actually rising. This wasn't a simple, gentle bulge, but a complex mosaic of localized uplifts, some areas surging upward much faster than others, creating a patchwork of movement. The total uplift was breathtakingly rapid, several centimeters in just a single year, a pace that defies what we expect from ancient mountains. To a geologist, that's like watching a mountain grow and fast-forward, compressing millennia of change into a matter of months. The Appalachians, formed over 300 million years ago, should be slowly eroding and shrinking, not growing taller before our eyes. The satellite data contradicted centuries of geological understanding, challenging everything scientists thought they knew about these ancient hills. Multiple satellites working in tandem with ground-based GPS stations confirmed the upward movement with remarkable precision. These GPS stations, anchored deep into the bedrock, validated what our eyes in the sky had detected, leaving little room for doubt. The message was clear and impossible to ignore. The Earth beneath one of America's oldest landscapes was stirring, coming alive in ways no one expected. The serene, rolling hills hid a powerful secret, their quiet beauty masking a dynamic force at work beneath the surface. The question was no longer if the mountains were rising, but why this was happening now, and what it could mean for the future. The race to understand this geological mystery had begun, drawing scientists from around the world into a new era of discovery. What does it mean for a mountain to experience uplift? When we talk about uplift, we're describing a powerful geological process that shapes the very surface of our planet. Simply put, the ground is rising in elevation, sometimes over thousands or even millions of years, changing the landscape dramatically. Imagine the Earth's crust as a thick rug. Uplift is what happens when something pushes up from below, causing the surface to bulge and form mountains or highlands. Mountain ranges are usually born at tectonic plate boundaries, where massive plates collide and thrust rock upward, creating dramatic peaks and ridges. But the Appalachians are in the middle of a tectonic plate, far from any active boundaries or obvious sources of uplift. Their mountain-building days were thought to be over, leaving behind ancient, weathered peaks that seemed destined to slowly erode away. The current uplift is different, mysterious, vertical, and happening in a supposedly stable region where little movement was expected. It challenges our models of how continents behave, forcing scientists to rethink what they know about Earth's interior. Isostatic rebound, where the crust rises after losing weight like melted ice, doesn't fully explain it, especially in this case. The speed and localized nature of the uplift suggest a new, unknown force at play, one that scientists are only beginning to investigate and understand. With the what and where established, scientists became geological detectives. The leading hypothesis, a piece of the lower tectonic plate beneath the Appalachians has broken off and is sinking, allowing hotter mantle to rise and push the crust up, a process called delamination. Another possibility, a new magma plume is assembling deep below, heating and expanding the crust. Some researchers consider rapid changes in surface water or erosion, altering crustal weight and triggering uplift. Perhaps it's a combination of these forces or something entirely new. The Earth is complex and its process is rarely simple. Each hypothesis brings testable predictions, but the truth is still buried deep below. The detective work has just begun. This isn't just a scientific puzzle, the rising Appalachians have real consequences for millions. Uplift puts immense stress on the crust, potentially triggering earthquakes. Even small quakes can damage infrastructure not built for shifting ground. Bridges, dams, pipelines, and buildings could be at risk as the land moves. The economic cost of monitoring and repairing infrastructure could be immense. Uplift can alter river flows, groundwater tables, and disrupt ecosystems. Habitats and water supplies could be affected, impacting both people and wildlife. This geological unrest reminds us of our vulnerability. The ground beneath our feet is not as stable as we believe. Understanding these changes is about survival and safety. The scientific community is mobilizing with urgency, responding to this unprecedented geological event. More GPS stations and seismometers are being installed across the Appalachians, expanding the network to capture every subtle movement. Scientists are creating a real-time high-definition map of the uplift, tracking changes as they happen. Seismic tomography will let us peer deep into the Earth, testing delamination and magma plume theories with new precision. Geochemists are sampling springs and gas vents for chemical clues from the mantle, searching for unique signatures. This is a global effort. Institutions worldwide are collaborating, sharing data and expertise across borders. Supercomputers are simulating scenarios to match the observed data, running countless models for accuracy. The goal, to predict how the uplift will evolve and what risks may follow for communities and ecosystems. The pursuit of knowledge is more urgent and inspiring than ever, driving scientists to push boundaries. We stand at the edge of a great mystery. The ancient mountains are speaking and we're just learning their language. This event reminds us that our planet is dynamic and full of surprises. Supporting science has never been more critical. The research needed to understand the Appalachian uplift requires investment and public support. When we invest in science, we invest in our future. Stay informed, support education, and champion scientific literacy. The story of the rising mountains is for all of us, a chapter in our planet's biography. Understanding Earth's rhythms is the most important task we face. The rising Appalachians are a message. There are still great mysteries to solve right beneath our feet.